That's not the doorbell. It's not the doorbell. Not the doorbell. Well, good morning. How are you guys today?
Good.
Good. Look at you, April.
I had like 3 alarms this morning.
You know, I'm just messing with you.
Oh, it's fine.
I don't mess with everybody. Wait on everybody to get logged in this morning. It's Thursday. It's the end of week 2. Can y'all believe it? And I guess we'll have to see how everything goes with all the schools starting back as to whether or not, hopefully we'll be good to start back in class on the 31st, as long as all the schools do okay. As long as we don't see a spike in numbers, hopefully we'll be able to come back. Morning, Easton.
Hey.
How are you today?
Good.
Good. Open my book and figure out where we left off.
We left up on page 34 and 35.
Thank you, dear. Wait just a few more minutes for everybody else to get logged in. While we're waiting, does anybody have any questions on anything so far? Everybody feeling okay about everything? Good.
So is a vertex like the degree and like the sides like obtuse and like acute and all that? Is that like what it is?
So the vertex is going to be the point where those two rays meet. Okay, so the vertex is actually a point. Okay, but we can name that angle based on that point. We can use the little angle symbol and the letter that is at that point. And then the degree of the angle is going to be what we're naming it: acute, right, obtuse, or straight. It's based on how many degrees it would be if you put a protractor on it.
Oh, makes sense.
Alrighty, so I guess we'll go ahead and get started. Looks like 1, 2, 3, 4, 5. Clara Jane. I know Keely is going to be joining a little bit later. And who else am I missing? I need to have my roll in front of me. Oh well, they'll join him. Alrighty, so let's go ahead and take a look where we left off. So we had started looking at segment and angle bisectors. So just a quick review for just a minute. I'll back up to page 34. So we talked about how And actually, let me go ahead and join my screen. All righty. Oh, there's Clara Jane. I thought I hit admit for Clara. Let's see, where's my list? She must be having trouble. There she comes. Okay, so really quick, we'll just kind of review our segment and angle bisectors. So we talked about how when we have a segment or a line and we have points on that line, when we talk about a midpoint of a segment, that means we've got our 2 points on the line, and then the midpoint is halfway in between those 2 points. And we talked about how you can use the protractor to draw the angles, to draw the little swoops and look at where they crisscross to know where to put your ruler to measure the angles. And then our bisector is going to be a line that intersects. It can be a segment, array, or a line, or even a plane that intersects with a line at a midpoint, okay? So whether you're talking about a midpoint or a bisector, we're talking about it's going to be halfway between the two, okay? The main difference is that a bisector is going to be a line and a midpoint is just a point, okay? So we'll move on to the next page, and we talked about the midpoint formula, that when I'm looking at points that are graphed on a coordinate grid, I can look at what the ordered pairs are for those points, and I can use the midpoint formula to figure out what point would be halfway between those on the graph. And to do that, I use my x coordinates and I add them together and divide by 2. Then I use my y coordinates, add them together and divide by 2. And that gives us a midpoint. So we're going to end up, our midpoint in this situation is going to end up as an ordered pair. So just like let's see, I'll start with a different color today. Just like we have right here, it's going to be written in parentheses as an x and y coordinate, okay? So that is our midpoint. So that's how we can use the midpoint formula. Any questions about that before we move on? Very good. All right, example 2 says finding the coordinates of an endpoint of a segment. So here it says, well, what if we have a midpoint and one endpoint? How could we find the other endpoint? So it says the midpoint of segment RP is the ordered pair 2, 4. One endpoint is R, which is -1, 7. Find the coordinates of the other midpoint. So the way that we would do that, and you can see where they graphed the midpoint and they graphed R, and then we had to figure out, well, what is this going to be over here? We can get graph paper and we can graph it and we can count, but the whole thing is when the line is slanted, you might not have perfect boxes to be able to count exactly up and down because our line may be going halfway through one of the boxes on the grid. So it says in the solution, let x, y be the coordinates of P. So we're letting that be x, y, and then use the midpoint formula to write equations involving x and y. Okay, so basically what they did here is this side is to solve for x. So they said, okay, well, if I have -1 plus x divided by 2 equals 2. So here they plugged in my x coordinate for my point that I know. That's where they're getting that -1. Then my x coordinate for what I'm trying to solve for is what I'm putting there. So remember how we add the 2 points together, and then whatever my solution is, is my midpoint, so that's where I get my x value from my midpoint, and that's what I'm plugging in. Okay, so once I've done that, I've set up my equation to where I have -1 plus x divided by 2 equals 2. Now we've got to think about how do we undo our problems to be able to solve for x. And in this situation, when I have -1 plus x divided by 2, remember the best way to solve is to think about whenever I have a fraction that I need to eliminate, the first thing I have to do is multiply by, you looking for your shoes? They're on the stairs. Sorry, hang on just a minute. Huh? Oh, that came in a bag. I don't know where it is. Sorry. Okay, so the first thing we need to do is multiply both sides of the equation by 2 to be able to get rid of that denominator. Okay, so when I multiply the left side by 2, now I'm left with -1 plus x. My right-hand side I multiplied by 2, and 2 times 2 is 4. Okay, so now I have -1 plus x equals 4. So now I need to add 1 to each side, and I end up with x equals 5. So now I know that for my, my point, I know that this number is going to be 5. Now I'm going to do the same thing for my y coordinate. I've plugged in y1, I've plugged in the letter y for y2, and then I've used my midpoint y as my solution. Again, I've got to start by multiplying both sides by 2 to eliminate the denominator. My 2's cancel here, and then 4 times 2 is 8. Now I have 7 plus y equals 8, so I need to subtract 7 from each side. So y equals 1. So this is where they have ended up with P is 5, 1. Okay? So we've looked at what if I have 2 endpoints and I need to find the midpoint. And now we just looked at what if I had the midpoint and one endpoint, how can I find the other endpoint? And we're using this same formula, we're just using it in different ways, okay? Any questions about that? Okay. Now we talked about bisecting a line a minute ago using the protractor, and this is just going to show how to draw a bisected angle, how to make sure you're getting the exact same measure. And like I said, using the protractor is something that we'll probably practice with if time allows once we return to the classroom. But for now, we're just gonna so you can see in the activity down here. Remember earlier when we looked at the segment bisector, we said you set your protractor to a certain thing where we know it's at least halfway. And so this is where, again, you swoop one way and then off of one point, and then you use the protractor off of another point and swoop again. And then you can find where those overlap and use your ruler to go from the point that's overlapped, which is right there, and it was right there in this picture. And so you want to line it up with the overlapping part and your vertex, and then you draw that line. And so that's how we end up with an angle bisector. And so that's what we're talking about right here. So an angle bisector is a ray that divides an angle into 2 adjacent angles. Remember, the word adjacent means side by side, that are congruent. Remember, congruent means equal. Okay, they're equal measure. So side by side, equal measure. In the diagram at the right, the ray CD bisects angle ABC because it divides the angle into 2 congruent angles. So now we have angle ACD and angle BCD. Okay, so it says in this book, matching congruent arcs, identify congruent angles in diagrams. So if we look at this right here, we know that these 2 angles are congruent because they have said that this angle is equal to this angle. So we know that each of the measures are equal to each other. Okay, so an angle bisector is something that cuts an angle into 2 equal smaller angles. All right, let's go ahead and move on to example 3. It's going to be on. All right, so example 3 is on page 37. Okay, so here it says the ray FH, we're dividing an angle measure in half with this one. So it says the ray FH bisects the angle EFG. Now, if we knew that the measure of EFG was 120, I want to figure out, well, then what is the measure of this angle and what is the measure of this angle? So by knowing that a bisector means it cuts it in half, then all I have to do is take 120 and divide by 2. So I know that this angle will be 60 degrees and this angle is 60 degrees. Okay, so by understanding my definitions, I'm able to apply that mathematically to figure out what the measure of these angles will be. So we find that if the measure of angle EFH is equal to the measure of HFG, that means I would divide 120 by 2, so each of them are 60 degrees. Any questions on that? All righty. Now we have doubling an angle measure. So we have a kite design. It says in the kite, 2 angles are bisected. So if we look and we have EKI, so that's going to be EKI is bisected by KT. So you can see that that angle is bisected by KT. Okay. Now we have ITE, which is right here. Which is bisected by TK. Okay, so we've got 2 angles bisected. Now notice that we have KT and TK. They're both describing the same ray, but notice on KT, my endpoint is K. On TK, my endpoint is T. Okay, so it says you're given the measure of one of the 2 congruent angles that make up the larger angle. You can find the measure of the larger angle by doubling the measure of the smaller angle. So if we look at this one, and we know that this angle here is 45, then that means this angle here is also 45. So what is my entire angle going to be? EKI. I would add
90.
Good. 45 plus 45 would be 90. Okay. So if I know that they are congruent, if I know that it's an angle bisector, now I just add them together to find the total angle measure. Same thing down here. If this one's 27 and this one's 27, I'm going to add 27 plus 27, and I'm going to get 54 degrees for this entire angle. Okay. So if I know one angle of congruent angles, then all I have to do is double it to get the measure of the larger angle. All right, now on this one, it says finding the measure of an angle. In the diagram, ray RQ bisects angle PRS. The measures of the 2 congruent angles are x plus 40 degrees and 3x minus 20 degrees, and I need to solve for x. Okay, so I've got to think about, I know that this angle is equal to this angle, so I'm going to set that up right here. So I have x plus 40 equals 3x minus 20. Okay, so what I need to do is the first thing, they added 20 to this side and added 20 to this side. So now we have x plus 60 is equal to 3x. Subtract x from this side, subtract x from that side. I have 60 equals 2x. Divide by 2, divide by 2. So x is equal to 30. Okay, so it says, so x equals 30. You can check by substituting to see that each of the congruent angles has a measure of 70 degrees. So just because we found that x equals 30, I have to go a little bit further, because if I'm trying to find what the measure of these angles are, that means I'm going to have to plug in 30 plus 40 equals 70 degrees. 3 times 30 minus 20 equals, that would be 90 minus 20, which would equal 70 degrees. So I'm still going to need to plug in the value for x to find what that degree measure is. Okay? Now, if the
how did you get rid of the degree sign, like in the problem right there? You added 20 and then the degree sign just went away.
well, I just didn't write it. I mean, it could be there. It doesn't have to be there, whatever. I just didn't write it. You just always want to make sure as you're doing the math, you don't have to necessarily keep the degree sign through it. You just want to make sure that if your answer asks for an answer in degrees, that in your answer you would have that degree sign. All righty. So let's go ahead and take a look at our guided practice here. Okay, so on our guided practice, this is on page 38. Good morning, Keely.
Good morning.
All right, so on page 38, the first question is, what kind of geometric figure is an angle bisector? So think about, if I've got an angle, and then I have an angle bisector, what kind of figure is this? What do we call that?
Ray.
A ray, good. So an angle bisector is a ray. How do you indicate congruent segments in a diagram? So what is, and actually, let's go back to that because we really didn't talk about that much. Let me flip back. Let's look at example 5 that we just looked at. So if I am looking and I'm trying to determine that segments are congruent, I can use these little symbols right here. And if I see that they are just one line and they've drawn it on the figure, that is an indicator to you that these two angles are the same measure. Okay, so sometimes you might see something that would look like this. So you can see that obviously these are not going to be congruent, and you would have one thing here and then two here. That indicates that they are different measures, okay? But like I have right here, if I have got the same arc drawn in the angles, that means that they are equal measures. Does that make sense? So in number 2, how do you indicate congruent segments in a diagram? It's going to be those matching marks, okay? And then how do you indicate congruent angles? Oh, hold up. So I just did the one for angles. The one that we just talked about with angles was the little swoops, okay? So congruent for segments, let's back up to segments. I didn't go far enough. Go back to my congruent segments. Okay, so you can see here, these little marks here are indicating congruent segments. It's the same type, it's just a little mark that's straight up and down. So if I see those two marks, then I know that those are going to be congruent. Likewise, if I had this and I had my my bisector here, actually let me change that. I'm going to put it right here. So then again, if I had a mark here and then I had a different mark here, I know that they're two different measures. Okay, so those little, in a bisector, it's going to be, I'm sorry, with a midpoint, it's going to be just those two little lines. But when I'm talking about array, bisecting an angle, it's going to be these little swoops or these little arched. Okay. All right, number 3 says, what is the simplified form of the midpoint formula if one of the endpoints of a segment is 0, 0, and the other is x, y? So let's think about this for a minute, okay? So if my midpoint, so remember we have x1 plus x2 divided by 2, y1 plus y2 divided by 2. So it's saying, well, what if one of the endpoints is 0, 0? So let's go ahead and put this in as 0 plus x2 divided by 2, 0 plus y2 divided by 2. I could simplify that as just having x2 over 2, y2 over 2. Okay, so it would just be whatever those other x and y coordinates are divided by 2. All right. Number 4 says find the coordinates of the midpoint of a segment with the given endpoints. So what I'm going to do is I'm going to start a new page. Hold on just a second. Okay, so let's take a look at this. First of all, let's think about our midpoint formula. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so this is number 4. And our point A is 5, 4. B is -3, 2. So I'm going to plug in and just have 5 plus -3 divided by 2, and then 4 plus 2 divided by 2. Now I'm going to simplify. 5 plus -3 will give me 2. So now I have 2 over 2. 4 plus 2 is 6 over 2. And now I'm going to simplify even further. 2 over 2 is 1, and 6 over 2 is 3. So my midpoint is going to be 0.13. Any questions on how we did that? Now, one of the things I want to mention there is I think in the Horizons book, for some reason, I want to say that they did x2 plus x1 divided by 2, but it's commutative, so it really doesn't matter the order. So don't stress too much about the order and what you're adding those, the x values and the y values, okay? Let's look at number 5. Number 5, A is -1, -9. B is 11, -5. So again, I'm going to set it up where I have x1 plus x2, plus x2 divided by 2, and then y1 plus y2 divided by 2. -1 plus 11 is going to give me 10 over 2. -9 plus a -5. Sorry, hang on just a minute. I don't know. I don't know if they have ones for them to wear or not. Sorry. Does he have his phone with him?
Yeah.
Do you want to try to text him? My son had late start today, and my husband just got home from taking him and realized he left his mask here. So I don't think he has a mask at school. So anyway, sorry. Okay, -9 plus -5 will give me -14 over 2. So again, now we're going to keep simplifying. 10 divided by 2 is 5, and -14 divided by 2 will be -7. So there's our ordered pair answer. Is everybody feeling okay with this? Just plugging it in where it goes, using that formula. if you need to write the formula, the blank formula, every time you work on something, write the formula. Number 6, A is 6, -4. B is 1, 8. I'm going to have 6 plus 1 divided by 2, -4 plus 8 divided by 2. 6 plus 1 is 7 divided by 2. -4 plus 8 is going to be 4 over 2. And so if you wanted to leave 7 over 2 as an improper fraction, you can do that, or you can write it as a mixed number. 3 1/2. 2 would be our midpoint. How's everybody with that? We have 2 points. We had to find the endpoint and the midpoint. All right, so now our next one for 7 through 9, it says find the coordinates of the other endpoint of a segment with the given endpoint and the midpoint. So remember in 7, when we have x1 plus x2 divided by 2, and then we have, actually, let me write it this way, equals, I'm going to do midpoint x. Totally making up my own thing there. And so then we have y1 plus y2 divided by 2 equals, I'm going to run out of room. Write a little bit smaller. y1 plus y2 over 2 equals the midpoint for y. Okay? So now in number 7, I have point C, which is 3, 0. Yes, Easton?
I didn't mean to, my bad.
Oh, it's okay, no problem. Okay, so C is 3, 0, and our midpoint is 3, 4. So now we're going to start with our x values, okay? So we're going to go ahead and put 3 in for our x1. We'll just put x for x2 divided by 2 is equal to, we're going to use that x value, which is 3. Okay, so we used our x1. We're using x as our variable for our unknown for our second number, divided by 2. We set it equal to 3, which is our midpoint x value. All right, the first thing I need to do is I need to eliminate that denominator. So I have to multiply both sides by 2. Man, go back. Too close to the margin. That's not where I wanted to be. Need my note. Okay, so we're multiplying that side by 2, multiplying this side by 2. These are going to cancel. So I've got 3 plus x equals 3 times 2 is 6. Trying to solve for x, and I have a 3 with them. It is a positive 3, so I'm going to have to subtract it to move it. So now I have x is equal to 3. So I've been able to find my x value for my other pair. Okay, so now we'll go in and we'll put in for y. And so my y value is 0. We'll plug in our variable y for our unknown, divided by 2 is equal to, we're going to use our y of our midpoint is what it's equal to. Again, I've got to clear my denominator first, so multiply this side by 2, multiply this side by 2. These are going to cancel out, and 0 plus y is just going to give me y, and 4 times 2 is 8. So now I know that my ordered pair is 3, 8 for that other endpoint. So this one takes a bit more of work. You know, we're having to go through it. righty, let's look at number 8. Number 8, our 1 point that we know is 5.2. Our midpoint is 7.6. So we're going to plug in 5 for our known x value, the variable of x for our unknown, divided by 2 is equal to the x value in my midpoint, which is 7. First thing I've got to do is eliminate that denominator. Multiply this side by 2, multiply this side by 2. Remember that as we're solving equations, we want whatever we do to one side, we have to do to the other side. That's how we keep it balanced, okay? So think about if you've ever used a balance scale, or if you've ever seen the pictures of like Lady Justice and she's holding the thing, and so you've got to make sure that, you know, if you add something to one side, it's going to make it off kilter. So you have to make sure to add the same thing to the other side so it balances out. That's why whatever we do to one side, we have to do for the other. Those of you that have had me before know I talk about brother, sister. If you have a sibling and your parents came in and gave your sibling $5, you expect to get $5 also, because we want everything to be fair. And so it's the same kind of situation here. If I'm multiplying one side by 2, I have to multiply the other side by 2. All right, so multiplying by 2 on the left-hand side eliminates that denominator. So now I have 5 plus x left on the left-hand side, and 7 times 2 is 14. I'm trying to solve for x. I've got a 5 with it. It is positive, so I've got to subtract it to move it. So x is equal to 14 minus 5 is 9. I've got my x value now. Now I need to find my y value. My y value that I'm given is 2 plus my variable y that I don't know, divided by 2 is equal to my midpoint y value that they've given me is 6. I'm going to multiply both sides by 2. Those cancel. So 2 plus y is equal to 12. Subtract 2, and y is equal to 10. So my ordered pair is 9, 10. All right, number 9, I want you to do on your own. I want you to work number 9, and then we'll look at it together. Okay, so while you're working, just so whenever you're finished, just look up at me so I'll know you're done. Okay, so go ahead and do number 9, following that same pattern that we were just using.
Out of nowhere, I got stuck, so I'm just gonna wait.
Okay, so what I want you to do is just look at your points, think about what you're going to plug in for the value that's given for x, use the variable for the unknown, divide by 2, What's going to go on the equal sign on the right side of the equal sign is going to be your X value for the midpoint. Then you'll do the same thing for Y. Plug in the number that you know for Y plus the variable Y divided by 2 is equal to whatever the Y value is for the midpoint. See if that helps.
Miss Jennifer,
Yes.
if you multiply -3 times 2, does that come out to 6?
Okay, so think about a -3 times 2. I have a negative times a positive. Think about your rules for sign numbers. A negative times a positive is going to give me a negative answer. Positive times positive is going to be positive. Negative times negative is positive. If they're the same signs, my solution's positive. Opposite signs, I have a negative solution. Those sign numbers are just things that we're usually pretty rusty on at the beginning of the year, and we have to get into the habit of doing those again. Everything okay?
Was he tall and long-headed? Well, he's long-headed, but not tall. Okay. Well, why don't I just give you this? Well, I don't have anybody to run it back there. You could text him. I can email him. Yeah, Carter's gonna get that. So I left it for him, I texted him, so we'll see.
Thank you. Sorry about that.
If I had an eight, I'd run it back there. Park your little ass back there. Jeez.
Okay, so let's go ahead and start taking a look at this. What I did is with the yellow, I drew arrows so you could see where I'm plugging in these values to the formula. Okay, so you can see where -4 is going to plug in for that X1 value. 2 will plug in for the Y1 value. Then for my midpoint ordered pair, -3 is plugging in for the midpoint X value, and -2 is plugging in for that midpoint Y value. So now I'm going to rewrite them like that. So I've got -4 that I'm plugging in for X1, plus x. I'm not going to bother. I mean, if you want to write x2 there, that's fine, but it's the only x I'm dealing with. So just to be quick and fast, I'm not even going to worry about doing x2. And so then I know that -3 is plugging in there. Okay, so I can use my arrows that I've drawn to know what's plugged in. If I have a fraction and I'm solving for a variable that is in the numerator of my fraction, I have to get rid of the denominator first. So that means I've got to multiply both sides by 2. These 2's are going to cancel. -4 plus x is equal to -3 times +2 will be -6. Now I'm going to add 4 to each side because my 4 is negative on the left-hand side. So x is equal to -2. Same thing for y. I can see that I'm plugging in 2 for y, so I'm going to have 2 plus y divided by 2 is equal to, now I've got a -2 that is being used for my value of the midpoint of y. Again, I've got to multiply both sides by 2 to be able to clear that denominator. So now I have 2 plus y is equal to -2 times +2 will give me a -4 since they're opposite signs. I'm going to subtract 2 from each side because 2 is positive on the left, and to move it I need to subtract it. And y is equal to, now I have -4 minus 2. Remember, if I start with a negative and I'm subtracting something, I'm going to end up with a larger negative, and -4 minus -2 is -6. So my ordered pair is going to be -2, -6. Thumbs up, thumbs down. Or maybe thumbs halfway sideways, however, okay? It's going to take a little bit of practice, okay? And that's okay. These are new concepts and just kind of thinking through everything. I think the key is understanding this part right here where we are figuring out what goes where, okay? That's most of your work right there, is making sure you get the right numbers in the right locations of your formula so you can end up with the right answer, okay? Any questions on that? Anything that you weren't sure why I did what I did? Clara?
I instead of putting -2, I put a +6.
On which one?
On the y value, where it says 2 plus y equals.
Uh-huh.
Where it equals 6.
Okay, so you put a 6 right here.
Right where it says 2 plus y equals, and that where that -2 is.
Oh, right here.
Yes, ma'am.
Okay, where did you get that 6 from?
I'm not really sure. I'm trying to figure out what it is.
Okay, well, I just wanted to make sure, because in your problem, you know, we had, for E, we had -4, 2, and for M was -3, -2. Okay, so it must have been just something where you saw something from somewhere else and you wrote that figure in. Okay, so we just are going to look at what that y value is for the midpoint, and that's the number that needs to plug in. Okay, so just practice with oh, hang on a minute. Sorry, it's Alec. I don't know, Alec's mom. I don't know if they're having trouble logging in. Okay. And actually, it's time for break. So we'll go ahead and break right there, and then we'll come back and finish our next guided practice, and we will move on with our angle pair relationships. Okay? All right, take 5. There we go.
Hello.
Good morning. How are you, Alec?
Tired. I've been sitting here for an hour.
Oh, I'm so sorry.
It's okay.
I'm so sorry. So were you just trying to log in for the other, for the Wednesday, or what was?
Yes,
what was the-
ma'am. It was Wednesday.
Yeah, there's different links for Wednesday and Thursday. Sorry about that. I know that's frustrating. So what you can do is I will get this video uploaded. It usually takes a little bit, but I'll get it uploaded as soon as it's able to. And that way you can just watch the beginning and catch up to where we are. Okay, we just finished in guided practice. We're on page 38.
Okay.
So we went through, let's see, we started on 34, I think. So we've done 34 through 38. So you're not too far behind. And we're in our break right now. So I'll give you a minute to get together, and it'll be all right.
Have we gone over homework?
No, we will just go over homework on Wednesdays.
Okay.
So next Wednesday, we'll go over the homework from yesterday and today.
I mean, like, have we like talked about the homework? Like, what's due next Wednesday?
Oh, I haven't assigned any homework. No, nothing's been assigned yet. We're almost there. We're working on the guided practice on page 38. And so this is where we're walking through it together. And then I'm about to give the assignment for this section. All righty, we'll go ahead and get started back. So now we're on number 10 on page 38. And it says that suppose that the measure of angle JKL is 90 degrees. So that's what I've written on my screen, is the measure of angle JKL equals 90 degrees. It says if the ray KM bisects angle JKL, what are the measures of angle JKM and angle LKM? Okay, so we know that we've got JKL is 90 degrees. So now what we're trying to do is figure out what is the measure of this one and this one. But it says that KM is a bisector. So remember, bisector means it is dividing it into two equal parts. So I'm going to have 90 divided by 2. And 90 degrees divided by 2 is going to equal what? Nobody wants to unmute and tell me.
45.
Pretty
45.
good. 45 degrees. So that means this one is 45 degrees. This one is 45 degrees. The bisector means it is cutting it in half. It is dividing it into two equal parts. So I take my total measure, divide by 2. Any questions on that? All right, let's look at 11, 12, and 13. So on 11, it says angle QS is the angle bisector of PQR. Find two angle measures not given in the diagram. Okay, so let's look at 11. Actually, what I'll do is I'll go back to my screen here. All right, so now here we are on 11. So if QS is a bisector and PQS is 40 degrees, then what is the measure of SQR?
degrees.
This is also going to be 40 degrees. Good. So angle SQR equals 40 degrees. So now what is angle PQR going to equal? Now I'm looking at PQR. Okay, so that means I need to take this 40, add that 40. So PQR will be 80 degrees. Everybody good with that? Good. Let's look at 12. All right, PQR, the whole thing is 64 degrees. So now that means I've got to figure out what is this angle? What is this angle? Again, we know that it's going to be a bisector. So I need to find the measure of angle PQS and the measure of angle SQR. So I'm going to say 64 divided by 2 is going to be 32 degrees. Everybody good with that one? If I know the whole angle, I'm going to divide by 2. If I know the measure of one angle, I'm going to make it the other angle the same measure and then add them together. And then finally, the last one, I know that SQR is 52 degrees. So that means the measure of angle PQS equals 52 degrees. So now I've got to find the measure of angle PQR. So I'm going to add 52 plus 52, and that will be 104 degrees. Any questions on how we did 11, 12, or 13? All right, so let's go ahead and look at what our homework will be. So on page 38, let's do 18 through 24 evens. Page 38, 18 through 24 evens. Now let's go to 39. We'll do 26 through 30 evens.
Wait, so on page 38, it's 18 through 24?
18 through 24, just the evens. You don't have to do odds, just the evens. Same thing with 26 through 30 on page 39. All right, then we are going to jump down and we are going to do 37 through 42 evens. 37 through 42 evens.
And this is due Wednesday?
This is all due next Wednesday, yes.
Okay.
And then on 40, we're going to do 44 through 48 evens.
On what page?
This is on page 40. So we'll go back through these real quick. So we said, page 38. That's 38, right? So page 38, we have 18 through 24 evens. Page 39, 26 through 30 evens. And then we also have 38 through 42 evens. And then on page 40, we have 44 through 48 evens. Okay, so we're doing midpoint formula. When we have two endpoints and we find the midpoint, we're then also using midpoint formula when we have an endpoint in the midpoint and we have to find the other endpoint. And then we are working with our angle bisectors and recognizing that a bisector cuts it in half. So we're looking for other angle measurements. So on 44 through 48, remember that since these are equal to each other, just like on 44, that means I'm going to set x plus 15 equals 4x minus 45. All I'm doing is setting each angle equal to each other and solving for x. Okay? Since we know that each angle, since it's a bisector, because our directions told us that they are bisectors. So that means each angle is equal to each other. So I'm going to set up my equations where I have one angle is equal to the other and solve for x. Okay, so pulling in some algebra here. Okay, any questions about our assignment so far? Everybody good? All righty, so we are going to move along over to page 44. This is section 1-6, angle pair relationships. Angle pair relationships. So this says that if we look over at our goals, goal 1 is to identify vertical angles in linear pairs. Goal 2 is to identify complementary and supplementary angles. Okay, hopefully you remember those words. If not, that's okay. We're going to go over them. All right. So it says in lesson 1-4, you learn that two angles are adjacent if they share a common vertex and a side, but have no common interior points. In this lesson, you will study other relationships between pairs of angles. Two angles are vertical angles. So the first word is vertical angles if their sides form two pairs of opposite rays. Now, one of the things I want to tell you, the way that y'all know I come up with all kinds of weird, silly things, and it may not make sense to you, but one of the things when I think of vertical angles, I am looking at if this angle here, notice it forms a V, okay? So whatever two angles have a V that's touching, those are vertical angles, okay? Or they're opposite from each other. Likewise, if I'm looking at 2 and 4, I've got a V going this way and a V going this way. So my two V's touch at the point. So I can tell, hey, these are vertical because my two V's touch. These are vertical because my two V's touch. Okay, so that's the way I remember vertical angles. Another way to describe them is opposites, okay? Because they're made from opposite rays. Okay, so verticals, opposites, think about the V's that touch. And it says two adjacent angles are a linear pair if their non-common sides are opposite rays. Sorry, hang on. Okay, so let's take a look at this. We talked about where the V's touch, so we found that 1 and 3 are vertical angles, and we found that 2 and 4 are vertical angles. So in this situation, remember how we used our little our arcs to show measurements? And let me do, so if I had that drawn as my little arcs, I can see that 2 and 4 are equal, right? And then here, I could put 2 there and 2 here, so I can see that 1 and 3 are equal. So I can use those little measurement lines, I can use those little arcs to show that 2 and 4 are equal because they've got the same little arc. 1 and 3 have 2 arcs each, so those are equal measures as well. Okay? So 1 and 3 are vertical, 2 and 4 are vertical. Now, if we come over here, 5 and 6 are a linear pair because their non-common sides are opposite rays. So what that means is the non-common side, you've got this one, and then you've got this one. And remember, they are opposite rays, and opposite rays form a straight line. So opposite rays form a straight line. So that's going to be the rule for opposite rays, but you know that these are linear pairs, angle 5 and 6. Okay, so it says in this book, you can assume from a diagram that two adjacent angles form a linear pair if the non-common sides appear to lie on the same line. So what they're saying is we can see that these are going to be adjacent angles because they are side by side on a line. All right, so example 1 says we are identifying vertical angles and linear pairs. All right, let's look at 2 and 3. It says, are 2 and 3 a linear pair? So I'm looking at 2 and 3. Look at their opposite angles, or look at their non-adjacent sides. Notice that this ray is going out this way and this one is going this way. It is not forming a straight line. Okay, so they're adjacent because they're side by side, but the non-common sides are not opposite rays because it's not forming a straight line. So they are not a linear pair. Does that make sense? Everybody good with that? They are adjacent, they are side by side, but because their non-common sides are not opposite rays, then they cannot be. All right, let's look at B. B says, are 3 and 4 a linear pair? So 3 and 4, notice what I've got right here. I've got a straight line. So they are a linear pair because their non-common sides are opposite rays and they do form they do form a straight line. All right. Angle 1 and 2, angle 1 and angle 3, are they vertical angles? Okay, look at 1 and 3. They are across from each other, but they're not forming vertical angles because they don't form 2 pairs of opposite rays. Okay, so remember, we'd have to have those 2 pairs of opposite rays that make straight lines. And this one little crooked guy right here is messing that up. Okay, so they are not vertical because I do not have opposite rays. The same thing with 2 and 4. 2 and 4 are not opposites because I do not have 2 pairs of opposite rays. Okay, the only time is if they're both straight, if they're intersecting straight lines. All right, so here's a little note down here that if 2 angles are vertical, they are congruent, and that's what we found up here when I put our little symbols for measuring. If I have 2 pairs of opposite rays and it forms my vertical angles, then each vertical angle is congruent. They're going to be the same measure. The other thing that it says that we can note here, that the sum of the measures of angles that form a linear pair is 180 degrees, because remember, a straight line is equal to 180 degrees. Opposite angles make a straight line, therefore opposite angles will equal 180 degrees. Okay? Any questions so far? All right. Example 2, finding angle measures. So we've just talked about how a straight line equals 180 degrees. So let's look at this example. And it says, if the stair railing shown at the right, if angle 6 has a measure of 130 degrees, find the measures of the other 3 angles. Okay, so what I'm going to do is I'm going to come over here, and they said that angle 6 is 130 degrees. So what does that mean the measure of angle 8 is? They're vertical angles.
130.
130 degrees, good. So angle 8 is also 130 degrees. Now remember, we just talked about how a straight line, actually let me pick a different color. We said a straight line is 180 degrees. So if angle 8 is 130 degrees, how can I find the measure of angle 5? I'm going to take my total of 180 degrees and subtract 130 degrees. And 180 minus 30 is going to be 50 degrees. So angle 5 will be 50 degrees. Now, if I had decided to do that with angle 6 and 7, I'm going to end up with the same thing, and angle 7 is going to be 50 degrees. Okay? So by knowing a straight line is 180 degrees, if I'm given one of my vertical angles, I can subtract to find the other. So that's what they've shown here. I know that angle 6 and 7 equals 180 degrees. Angle 6 was 130 degrees. My total was 180, so I can subtract to find that it's 50 degrees. And since angles 5 and angle 7 are vertical angles, that means that they are congruent, so both of those will be 50 degrees. And since angle 8 and angle 6 are vertical angles, they are both going to be 130 degrees. Does everybody feel comfortable with that? Vertical angles are congruent. Vertical angles are going to be the same measure because they're congruent. A straight line is 180 degrees. So if I know one of my angles, I can just subtract it from 180 to find the other. Okay. All right, now they're going to throw some algebra at us again, and they're going to use that skill that we just learned, knowing that vertical angles are congruent. And so now they're going to say, okay, now I want you to solve for x using that information. So if we know that the measure of angle AED, so here we have AE, and actually let me get a different color so it'll stand out. So if we have AED, we know that that one plus DEB, so now we're going DEB. We know that when we add these two together, they are equaling 180 degrees because they make a straight line, okay? So that means I can set 3x plus 5 plus x plus 15 equals 180 degrees. Okay? So 3x plus x is 4x, and 5 plus 15 is 20. So I've been able to simplify that to 4x plus 20 equals 180. Now I've got to subtract 20 from each side, and I have 4x is equal to 160. Divide by 4, divide by 4. So I find that the measure of angle x is 40. I'm sorry, not angle x. The measure of x is 40. Okay? So then what I'm going to have to do if I wanted to find out what 3x plus 5 equals, then I'm going to put in 3 times 40 plus 5. I can substitute my value of x. So 3 times 40 is 120 plus 5 is 125 degrees. So now I know that this one is 125 degrees. Well, since angle since these are vertical angles, then I know that this side is also going to be 125 degrees. All right. Now I can also know that if my straight line here is 180, and I just found that this one is 125 degrees, now I can subtract, and I can have 180 minus 125. So 10, that's going to give me a 9. So I end up with 75 degrees. So that means this one will be 75 degrees, this one will be 75 degrees. Okay? So really, I can use any of these measures to be able to find, no, I did that wrong.
Would that be 55?
Well, when I borrowed, yes, because when I borrowed from my 8, I'm at 9. When you borrow from an 8, it does not become a 9, it becomes a 7. And then 7 minus 2 is 55. Thank you. Okay, so we end up finding that 2 of our angles are 125 degrees. The other 2 angles are 55 degrees. And again, I don't have to actually plug it into all of these to solve. I mean, you can see where they did that, but once I know one of those angles, I'm able to solve all of them by understanding my straight line is 180. I plug in the one that I know, I transfer it for the vertical angle, and then I can solve for the adjacent angle that is vertical with the other one. Okay. All right, so our next section is talking about complementary angles and supplementary angles. And it says two angles are complementary if the sum of their measures is 90 degrees. This is something that you need to know and that you need to remember. I'm going to highlight that in pink since it's already highlighted in yellow. Oh, nope, go away. We'll go over this way. Two angles are complementary angles if their sum is 90 degrees. Each angle is the complement of the other. Complementary angles can be adjacent or non-adjacent. So we can see in the first two examples, I have complementary angles that are adjacent because they're touching. Okay, and so these are adjacent because they're side by side. These are non-adjacent because they are not touching. They don't match up on a side, okay? Don't have a common vertex. But just because they're not touching doesn't mean that they can't be complements. So in the first one, angle 1 plus angle 2 equals 90 degrees. So angle 1 plus angle 2 equals 90 degrees. Same thing here, angle 3 plus angle 4 equals 90 degrees. So if I knew the measure of angle 3, I could subtract that from 90 to find the measure of angle 4 by understanding that complementary add together to equal 90 degrees. The next one is supplementary angles, and angles are supplementary if the sum of their measures is 180 degrees, or it makes a straight line. Supplementary, 180 degrees. So think about one of the things here to remember the difference between supplementary and complementary. Think supplementary, straight line, two S's, supplementary and straight, 180 degrees. So if you know that a straight line is 180 degrees, you know supplementary makes a straight line, you know that supplementary is 180 degrees. Okay, so trying to make these connections here. So again, we have supplementary adjacent angles, meaning that they are side by side. So when I would add angle 5 plus angle 6, that will equal 180 degrees. 7 and 8 are non-adjacent because they are not touching, they are not side by side, but still, because if it tells me that they are supplementary, then that means the measure of angle 7 plus angle 8 will equal 180 degrees. How's everybody feel about that? Complementary 90, supplementary 180. Okay, so they are giving us some clocks to take a look at here, and it says state whether two angles are complementary, supplementary, or neither. Obviously, the neither part, you're going to have more chances of something being neither because it's either 90 or 180 or anything else, okay? So it says letter A. I'm sorry. It says the angle showing 4 o'clock has a measure of 120 degrees. So what they're saying is that this one is 120 degrees. The measure and the angle showing 10 o'clock has an angle of 60 degrees. Because the sum of these two measures is 180, 120 plus 60 equals 180, so they are considered supplementary angles. Whoop. I guess Easton bumped out.
It said I was kicked.
Huh?
It said you have been removed from this meeting. I don't know why.
I don't either. I don't know what happened. Sorry about that.
You're good.
Okay, so we just looked at the clock and we saw where one of them measures 120 degrees, the other one is 60 degrees. If I add 120 and 60, that's 180, so they are supplementary. Example 5 says, given that angle A is a complement, 90 degrees, of angle C, and angle A equals 47 degrees, then I need to find the measure of angle C. So what I would do is I would use that 90 degrees and subtract the measure of angle A. So 90 minus 47 is 43 degrees. So the complement would be 43 degrees. Letter B, given that angle P is a supplement of angle R, supplement 180, and angle R is 36 degrees, I need to find the measure of angle P. So again, I'm going to start with knowing that I have 180 degrees as my supplementary angle. I'm going to subtract the angle that I know, which is angle R. So I've got 180 minus 36. So the supplement would be 144. Okay. All right. The next one says finding the measure of a complement. Angle W and angle Z are complementary. The measure of angle Z is 5 times the measure of angle W. Find the measure of angle W. So I've got to take this apart and think about it, okay? I know that based on what they've told me, angle W and angle Z are complementary. So that's what I can see right here, where I have the measure of angle W plus the measure of angle Z equals 90 degrees. But it tells me that the measure of angle Z is 5 times the measure of angle W. So that's where you can see they put 5 times the measure of angle W there.
450?
I'm sorry?
450?
Okay. So it says, so the measure of angle W plus 5 times the measure of angle W is 90. So if I have 5 times the measure of angle W plus the measure of angle W. So think about this for a minute. That means I've got 5 times the measure plus a measure. So that means I have 6 times the measure of angle W is 90 degrees. So if I divide by 6 and divide by 6, then the measure of angle W equals 15 degrees. Okay. So let's go through our guided practice. And it says, explain the difference between complementary angles and supplementary angles. So what is our big difference here? Complementary equals
90 degrees.
90 degrees. Supplementary equals
180.
180 degrees. So supplementary angles are twice as big as complementary. Okay? Supplementary angles are going to be 2 times complementary angles, since 180 is 2 times 190. I'm sorry, 2 times 90. All right, number 2 says sketch examples of acute vertical angles and obtuse vertical angles. So all I have to do is I can draw my 2 intersecting lines. And actually, let me do. If I drew intersecting lines that are both straight lines, then I can see that these are my acute angles and these are my obtuse angles. Okay. They are vertical because they're directly across from each other where it forms a V. Then it says sketch examples of adjacent congruent complementary angles and adjacent congruent supplementary angles. Okay, so if I'm looking at this one, I'm going to have, let's see, let me find a little place, I'll come over here and write adjacent congruent complementary angles. So I'm going to have That's going to be like our example, not that. That would be like our angle bisectors, and we know, and I know that they're not perfectly, they're not going to be exactly the same because I'm freehanding it. Okay, but that's going to be about the same. So we know that it's going to equal 190, and we know it's going to equal 90 degrees. Or you could even have it, even if, let's say you wanted to, you could draw it like that even. But they are adjacent because they're side by side. Oh, it says congruent. It does say congruent. Sorry, I was just doing adjacent complementary. It does say congruent, so they would have to be, whoop, it's going to have to be a bisector. Okay. And then adjacent congruent supplementary angles. Again, I'm going to have my straight line. Now I'm going to have, whoop, that's not going to be a good bisector. Let's start from here. So that would be our adjacent congruent complementary angles. Okay. All right, so let's look at number 4. It says finding angle measures. Find the measure of angle 1. What do I know my straight line equals? 180 degrees. So if the whole line equals 180 and I'm given 60 degrees, the measure of angle 1 is going to be 180 minus 60.
120.
Which is going to be 120 degrees. That looks like a... Now let's look at number 5. Again, my whole line equals 180 degrees. So if my given angle is 160, 180 minus 60 is 20 degrees.
I need your consent on a few items.
Number 6. Okay, this is going to be a little tricky here because look at what we've got. I know that if this is a right angle here, then that means this is a right angle here. What does a right angle equal? 90 degrees, right? So first I've got to find this here. So 90 degrees minus 35 will give me 55 degrees. We know that this angle here will be 90 degrees. So if I added 35 plus 55 plus 90, that's going to give me 180 degrees. Any questions on those? Okay, so number 7 says opening the door. The figure shows a doorway viewed from above. If you open the door so that the measure of angle 1 is 50 degrees, how many more degrees would you have to open the door so that the angle between the wall and the door is 90 degrees? So basically what they're saying is if you wanted this to make, actually let me do a different color. If you wanted to open the door to where it equals 90 degrees, and we know that right now this is 50 degrees, how many more degrees can I open my door?
40.
40 degrees, good. Okay, so when I know that complementary equals 90 degrees and I'm given something, I know I'm just subtracting 90 minus whatever. When I know that supplementary angles equal 180, I just take whatever I know, 180 minus what I know is going to give me the supplement. Okay, so, but knowing those angles are super important. You must know complementary 90 degrees, supplementary 180. Okay. Okie doke. Let's go ahead and take a look at homework for this section. Let's look at our time. We are at 10:07, so we are rocking right along. Okay, so we are going to be on page 47 for homework. So page 47, let's do 8 through 18 evens. Actually, yeah, 8 through 18 evens. Then we're going to turn the page to 48. And we will do 20 through 36 evens. And then on page 49, let's do 42 through 52 evens. Okay, so I'll repeat that. Page 47, 8 through 18 evens. Page 48, 20 through 36 evens. Page 49, 42 through 52 evens. Any questions on any of those?
Did you say 42 through 52?
Yes, evens.
Thank you.
You're welcome. All right, so it looks like we have one more section left in this chapter. So if we'll go ahead and we've got just a couple of minutes, let's go ahead and look on page 1.7. I'm sorry, page 1.7, section 1.7 on 51. And it says, we have an introduction to perimeter, circumference, and area. Okay, so remember when we talk about perimeter, perimeter is like putting a fence around a yard. Okay, perimeter is the distance around a figure. Okay, when we talk about circumference, that is the distance around the outside of a circle. Okay, so perimeter and circumference are similar in that they're talking about the distance outside, but perimeter is when I have straight sides, and circumference, I've got a circle. Okay, and then area is going to be what is covering the middle part of it. So when I'm talking about the area of a square, when I think of area, that's when I think of carpet. Okay, so perimeter would be putting paint on the walls. It's on the outside of the room, but area is going to be putting the carpet down. All right, so on Wednesday of next week, when we meet back, we will go over all of our homework answers for yesterday and today. Then we will start on our perimeter, circumference, and area. And then we will go ahead and put together our study guide for our first test that will be sent home next Thursday. Okay, so we'll be looking at these formulas for perimeter, circumference, and area on next Wednesday.
Are we gonna have to wear a mask in class?
So if and when we return to the classroom, it will depend on what the state mandate is. If, as of right now, the mask order is supposed to expire August 31st. If that gets extended, then we will need to wear a mask. Now, at the co-op, it has been decided that a face shield is acceptable. So if wearing a mask is uncomfortable for you, as long as you have a face shield that comes above your eyes and below your chin, then you can use a face shield. That is probably what I will be wearing when I'm teaching, because I don't want my voice to be muffled, especially if people are live streaming the class. I don't want to be muffled with something y'all can't hear me. So I have a face shield that I'll be using if and when we return to the classroom, if that order is still in place. again, that's going to be a co-op decision. My assumption, just based on how things have been in the past, if the state mandate is still in order, then we will have to wear them. Now, I know from what I understand, at my kids' school, what they're doing is they are allowed to take their mask off if they can be 6 feet apart. I don't know how that's going to work in our classroom. I'm not sure what it'll be. You know, obviously it's the kind of thing that if we don't have masks on, we'll need to, you know, not be talking and whispering to each other and stuff like that because transmission. The good news is if you look, the most recent thing I saw was where they had each county in Alabama color coded. And I know that in mid-July, Shelby County was a red county where it was like a high transmission rate. We have gone from red to orange to yellow. We are now a green county to where, because people have been wearing masks, the transmission rate has dropped tremendously. And so it's working. So that's a great, exciting sign. So my thing is if wearing a mask, if I have to wear a mask to be able to go back to school, by golly, I want to see y'all in the classroom. I want to be able to be with y'all. I'll wear a mask. I'll wear a face shield, whatever I need to do for us to get back to some semblance of normalcy. So anyway, we'll see what happens. My guess is that if the mandate gets extended, then obviously we'll have to wear masks. But if it doesn't, then I think it'll be up to each individual family to decide. So basically that'll be up to your parents on what they want you to do. Okay. All righty. So if y'all have any questions, be sure to let me know. I am teaching the rest of the day until 2:25. So if you shoot me questions or anything between now and 2:25, I'm not going to be able to answer until later this afternoon. As soon as the video is uploaded, I will be posting it to the YouTube page. So if you need to tune in and review anything or catch up on anything, that will be posted probably, hopefully, you know, if it'll be done by 4 o'clock, if not before. So anyway, but if y'all have questions, be sure to let me know. And if not, then I will see you guys next Wednesday. Okay?
Bye.
Bye.
Bye, guys.
Bye, thank you.
You're welcome, hon. Thank you.